So if you want to do TLC fingerprinting, there are basic things that you need. One is a TLC plate. In this particular case, I am using this type of TLC plate, which is silica gel 60 F254. You need capillary tubing. Okay, so basically they're actually things you can use for spotting, but in this case we are going to use a capillary tube. This is what it looks like. Okay, and please make sure that when you are getting the capillary tube, it is not heparinized. So this is what they call non-heparinized capillary tube. So you use it to draw out the extract and spot on the TLC plates. And you need a TLC tank. In this case, you can improvise with a jam jar like I did here, and you can label your jam jar with the solvent system that you're going to use. In this case, I did H to E. H is hexane, E is ethyl acetate, so 6 hexane, 4 ethyl acetate. So usually when I'm doing this, I do 10 mils. So I measure 6 mils of hexane and 4 mils of ethyl acetate, and I mix it and add it to this tank. And then you will need filter paper. So basically the filter paper, what the purpose it serves is to show you when the tank is saturated with the solvent. So when you put the solvent into your TLC tank, which in this case we are using this glass jam jar, you will drop in a filter paper like so and quickly cover it, and then you'll be watching the filter paper. So what you're going to notice is, you notice that the solvent will begin to rise by what we call capillary action until it gets to the top. So when it gets to the top, what that tells you is that this TLC chamber is fully saturated. So when it's fully saturated, you can put your TLC plates. I use this solvent system for a particular plant, what we call Iyeye or Spondias moonbeam. All right, so I worked with this plant a lot. So I figured out, through a lot of TLCs, that this is the solvent system that brings out the best TLC profile on the TLC plate, and that's what I use for identifying my extracts. So lest I forget, of course, you will also need your solvents. Like I told you, I use ethyl acetate and then hexane. Now, what you need to know, things you need to know about TLC fingerprinting is that if you want to do a TLC fingerprinting, you have to make sure that everything is uniform. That means that the solvent you are using is the same type. For instance, let me use these two solvents I'm using as an example. The ethyl acetate you are using must be the same type analog. Okay, the hexane you are using, if it is hexane fraction from petroleum, it must be the same type. The stationary phase, which we call the plates, the one that is not liquid, the stationary phase must be the same. The ratio must be the same. So when you have a plant, for instance, like the Spondias moonbeam I was talking about, which we also call Iyeye, if somebody supplies you Iyeye powder and you don't know whether it's adulterated or not, you prepare it, the extract, the exact same way you make it normally, which is, let me show you, I just did an improvised one here, which is soaking Spondias moonbeam in acetone for 3 days. Okay, and then you spot it on a TLC plate, and then you put it inside saturated TLC tank, and then you allow it to develop. When you finish developing, you bring it out from the tank and you check the spots. So you would have had a reference already, the one that you've done before, which is what you will keep, and you'll be using it as a reference point. So you can even snap a picture of it and keep, and when you label that picture, reference for Iyeye. So when they bring another Iyeye to supply to you and you're not sure, in fact, whether you are sure or not, you must always do these tests, and they're very simple and very easy to do. You spot, you develop in the tank, and you bring it and you place it side by side together with your reference. If they're identical, then you know that you have the correct plant. There are other aspects of the TLC which I need to talk about, or I need to let you know. For instance, this ratio I did not just arrive to it by chance. I did a series of experiments where I started with maybe 1 hexane, 9 ethyl acetate, then 8.5 hexane, 1.5 ethyl acetate, like that, several TLCs, and then I looked at them and I saw which one was the best before I got this. That process is what we call optimization, and I am going to do optimization with another extract, which is an extract I've not worked on before. I mean, an extract I've not done TLC before on, or TLC optimization before on, which is this one, which is an acetone extract of bitter leaf. So I am going to optimize the TLC of this to show you how you can do that to arrive at a solvent system that works best. So that's what we're going to do that one later. But first, let me teach you the one we know, which is the Spondias moonbeam. We have to actually cut the TLC plates. So let me show you an example of a cut TLC plate. You can see it. This is actually Spondia spinata. Okay, look at the way I cut it. Okay, let me keep this. So let me show you. These are various cut TLC plates that have not been used. And then this is what the TLC plate looks like. It's like a thin paper like whatever. And then look at the back, made of aluminum. Okay, so this is 20 by 20 centimeters, 20 by 20 centimeters. Now you can cut it, actually cut it into different sizes. So to get this, I first of all cut this into half and then cut into 4 and then start cutting. So you actually need to measure it with a ruler. Okay, and what works best for cutting TLC is not scissors, even though you can use scissors, but this actually, because this will cut. So you will mark the this thing and put a clean sheet of paper and cut. So I'm going to show you how to cut it. Look at the sheet. You must make sure that nothing stains this sheet. Okay, so you take out a sheet and then cut clean sheets of paper to protect it, and then you place it on top of the clean sheet of paper. This is a clean paper, so it's not going to affect it. Two, three, four, 5. So we can use this for single spots. However, you might want to have something that has 2 spots, so you want to be wider. All right. Okay. So even if you make mistakes, it doesn't matter. So that's how to cut the TLC plates. Let's say you ask somebody to supply Spondia's moonbeam leaves, also known as Iye, to you, and the person brought this, and you are not sure if it is actually Spondia's moonbeam or Iye. What do? Very simple. You can do a TLC fingerprinting of this plant powder to be able to identify it and to be sure that it is Iye or Spondia's moonbeam leaves. So what I'm going to teach you is how to actually do a TLC fingerprinting of this herb. Now, why I'm using Iye is because I worked with it for my PhD and I know everything about it inside out when it comes to TLC. So I have already gone ahead and done something called TLC optimization. And when I did that, I already figured out what solvent system will be the best to use for doing the TLC. That is 1. 2, I've already figured out what solvent to use to do the extraction. Now, when you are doing TLC fingerprinting, everything must be exactly the way you did it first. Your solvents must be the same. The solvent system must be the same. The TLC plate you are using must be the same. Everything must be identical for you to be able to get something that is reproducible. So the goal is for you to be able to do this test and get a fingerprint which you can always be able to use to tell if that plant is genuine or not. First of all, what I did was to do an extraction. So this is Spondias. So this is a small extraction. So what you need to do is just to do a small extract. As you can see, the extract, the liquid inside. You take the plant material, soak it inside the solvent. Mind you, remember what I said, everything has to be the same. Soak it inside the solvent, filter, take the liquid, and it is the liquid that you will test with your TLC. Okay, so I've already gone and I've soaked this inside acetone. I use pure acetone for this extraction. Mind you, this is quite a lot. You can actually do something much smaller. You can take like a quarter of a teaspoon of the powder and about maybe 5 mils of acetone to do this same extraction. The goal is just to get a little bit of the liquid, which is the liquid extract. Okay, so I'm going to filter out some of the extracts, which is what I am going to use for the TLC. Okay, so when you want to filter, you first of all fold this into half, then you fold it into a quarter, okay, and then you bring out this part like this, so you form the funnel, as you can see, and then you take that funnel and you place it on your funnel, and then you can filter. So I just need a very small amount, so I'm going to filter this. That's the extract, that's the plant material with the solvent, which is acetone. So I'm going to pour some here so that it can filter, and I will leave it to filter. Here you can see it's filtering. Actually, don't even need more than like 10 drops. I'm just doing this. This is quite a lot already for the TLC, but I'm just going to filter it. I may eventually pour it back into here. The extract, I filtered it. Okay, this is the TLC tank that we're going to use, which is a glass jar, jam jar. Okay, so what I'm going to do is measure hexane and ethyl acetate in a ratio 6:4. So that's hexane and this is ethyl acetate. So I'm actually going to mix it inside the measuring cylinder, which is a 10 ml measuring cylinder. So what I'm going to do is I'm going to mix 6 ml of the N-hexane or hexane and then 4 ml of the ethyl acetate. Okay. Ethyl acetate. So that's 10 ml. So I'm going to pour it here. Pour it and mix very well. Then take the filter paper and put it inside. Okay, like this, and cover it. Please, when you are doing this, make sure that you don't leave this open for too long so that the solvent doesn't evaporate. So the purpose of the filter paper is for it to tell you when the TLC chamber has saturated. So if you look carefully at it, you will see that it is beginning to saturate. Okay, so that is the filter paper. You are going to see the solvent rising up the filter paper. So when the solvent gets to the top of the TLC chamber is when you know that it is fully saturated, and that's when you can put your TLC plate. So if you put your TLC plate now, you're actually not going to get a good result. Okay, why? Because it's not fully saturated. You can see the filter paper is barely even half gone. All right, so it has to rise to the very top, then you know that it's ready. So it takes some minutes depending on how volatile the solvent is. So we're going to set this aside and allow it to saturate very well while we start doing our TLC plate. So let me set this aside carefully. The TLC. So what I'm going to do is I'm going to actually mark some boundaries on it, and I will explain. Now I can't find my pencil, so I'm going to use this, which I'm still going to use anyway. So I'm going to use this to mark the boundaries on the TLC plate. Okay, so this is a capillary tube. It's very thin and it has a hole inside. So this is actually what we use for drawing the solvent and spotting on the TLC. But first of all, we have to mark it. All right. Sorry, pardon my ruler. So what I'm going to do is, I already know the measurements, but if you are going to do it, you measure. So you measure 1 cm and mark, and measure 1 cm from the bottom and mark. So this should give about 1 cm. So I'm going to mark it lightly. Okay, so and then I'll mark another 1 cm. This time I'm going to mark it very well so that you can see it. Not lightly. Okay, so you can see this one is well marked, while this one is slightly marked. So what I did was to mark here and mark here. Okay, so we refer to this mark here as the origin, and we refer to this mark here, this one here, as the solvent front. So what is going to happen is that when you spot your sample, it's going to rise up. The solvent will push it up the TLC plate until it gets to the solvent front. So you ideally want it to rise, the solvent to rise and get here, and then you quickly take it out of the TLC tank. That's reduced in size because it's an acetone extract and most of the solvent has evaporated. So this is how you take it. You put the capillary tube inside. When you do that, what happens? It draws up liquid. Now, you take your hand and use it to cover here, and then you spot it on the origin, which the origin is somewhere here. So you see that there is a spot there. Okay, so that is your extract. So you're going, once you spot it, it has to dry completely on the TLC plate before you put it inside the chamber. So we're going to wait for this to dry, and then when it's fully dry, we'll check our tank and see if it's fully saturated. If it's fully saturated, then we'll place it inside and then allow it to develop. So as it's developing, when the solvent gets to this place, we would bring it out and then you will see the results. Okay, so the TLC tank is saturated. If you look inside, you see that all the solvent has risen to the top of the filter paper. So you know that it's now time for us to put the TLC plate into the solvent tank. Now, quick one, because this is a tutorial and I'm teaching you everything you need to know. This is the TLC tank, okay, or TLC chamber. Once you have put solvent inside it it has to stay in one place. If you are moving this, don't just fling it and fling it. To cause a lot of problems, because it will upset the equilibrium of the vapor of the solvent that is inside. You get? So if you are moving it here and there, it has to be done carefully. Now, if you have mistakenly pushed it like this, for instance, you have to leave it for like maybe 20 minutes to calm down before you put your TLC plate. Okay, so we are going to now put our TLC plate. So carefully open it, and then put it inside, and then you collect. Okay, so what can you observe? You're going to see. Now I'm going to, let me make this so you can see what. Okay, so now you can see that the solvent is actually pushing, going up. Remember, this is our solvent front, this line here. It must not go above this line. Once this solvent gets to this line, we are going to bring it out. Okay, so check out what is happening. What do you see? You are seeing different spots separating out. This was this. Remember, this was the extract, spondylar's moonbeam extract that I spotted on the TLC plate. Don't forget, that's it at the origin. But look at what is coming out. You can see other things are coming out and are being pushed forward. You see up here is a yellow stuff. This yellow stuff is actually an oil, and it's a mixture of several compounds. I've separated it out before. Okay, I have it in my what do you call it, archives from when I went on a research trip abroad. So it's a complex mix. This dark one, actually two. One is dark, the other one is a little bit more green. They are what are called phytins. They are derivatives of chlorophyll. Okay, I also isolated some of them. So let's watch it as. I'm going to bring it out. There. So there you have it. This is the TLC fingerprint of spondylar's moonbeam. So you can see that the solvent, you can see it's still wet, it's still drying. So there you have it. So this is how you do TLC fingerprinting. Now, if you have, for instance, you have a leaf, somebody supplied this, and you quickly run this test, and it gives you this exact same profile, you will know that what you have is authentic. Okay. So this is an example of qualitative analysis. That is, it's not quantifying or telling you the quantity of each of the components, but it's just telling you that it contains these components. So I will tell you for a fact that this TLC fingerprint is the same TLC fingerprint I have been getting, that I was getting from 2010. I was working with this particular plant. It's the same thing. So I can confirm that the spondylar's moonbeam leaves that I used, that I used, is exactly spondylar's moonbeam. And this fingerprint proves that.